Hi, I'm Muhammad, and today I'm going to be talking about automotive energy density and efficiency. The purpose of this presentation is to get an understanding of the effects of energy density, the effects of thermal efficiency, and have an understanding of the design constraints relating to specific energy. To start, we have energy density, and the definition of energy density is energy stored per unit volume, typically watt-hours per liter, or as we'll use later, watt-hours or megajoules per gallon. Here we have E10 gasoline, which is just gasoline with 10% ethanol. It's the most common form of gasoline found. Then we have nickel metal hydride, which is the chemical substance used in hybrid vehicle batteries. Then we have lithium ion batteries. Here we have the watt hours per liter converted to megajoules for each substance. And then also we have watt hours per gallon just for later calculations. The three vehicles being studied are a 2012 Honda Civic with a 1.8 liter gas engine, a 2012 Toyota Prius with a 1.8 liter hybrid engine, and a 2012 Model S with an 85 kilowatt hour lithium ion battery. You see we have the fuel efficiency for each vehicle listed here below. We have the city and the highway efficiency. If you'll notice, the Tesla Model S has MPGe, which is the fuel efficiency equivalent of how many miles it can go based on the equivalent energy of 1 gallon of gasoline, which is 33 kilowatts per gallon. We're going to start by looking at the energy required to move 250 miles. The big assumption we're going to make is that the hybrid and the electric vehicle have the best battery available, the purest and best available components. The Honda Civic would be able to go 250 miles on 8.9 gallons in the city, and when you convert this over, you get 300 kilowatt hours consumed, or 1,708 megajoules. For the highway driving, it's going to consume 6.4 gallons, which converts over to 776 megajoules. The Prius for city driving consumed 4.9 gallons, which converts to 594 megajoules, and in the highway consumed 6.4 gallons and 630 megajoules. The Tesla Model S, it's rated for city driving at 265 miles on its 85 kilowatt hour battery, which comes out to 306 megajoules. And on the highway, it's rated for a 250 mile range, also from its 85 kilowatt hour battery. It should be noted that the volume of the batteries for the Tesla is going to be 32.8 gallons. That's the volume taken up by all the battery packs. The thermal efficiency is the percentage of energy turned into useful work. The rest of it will be lost to heat or friction, mechanical losses. Typical internal combustion engine efficiency is about 33%. For hybrids, it's approximately 40%. And for electric vehicles, it's actually approximately 92% due to the efficiency of the electric motors. Looking at just city driving, we can see the Civic consumed 1,709 megajoules, which when you take 33% of that, you get 356 megajoules used just for motion. The rest of it was lost to heat. The Prius consumed 594 megajoules, and thus 237 megajoules were used just for motion, just for driving the 250 miles. The Tesla consumed 306 megajoules, and thus it used 281 megajoules for motion. The specific energy is the energy per unit mass, typically watt hour per kilogram. Looking at the city driving again, the Civic consumed 56.7 pounds of gasoline. The Prius consumed about 31 pounds of gasoline. The Tesla uses an 85 kilowatt hour battery, which ends up weighing approximately 1,200 pounds. All these factors are things that should be taken into consideration when designing anything, especially vehicles. Electric motors have very high efficiency compared to internal combustion engines. However, space or weight can be an issue. especially considering the batteries take up 3 to 6 times the volume to move the same distance, and they also end up weighing 21 to 38 times the mass compared to gasoline that would have been used in a internal combustion engine or in a hybrid engine. Thank you.